So our first question involving universal gravitation asks us if the force of gravity at Earth's surface between the Earth and a 40 kilogram mass is 392 newtons, what would be the force of gravity when the mass is lifted to a height equal to the Earth's radius? So the first thing we want to do is determine how to solve this problem. And we can solve this problem by using a version of the inverse square law, which states that the ratio of the gravitational forces equal the ratios of the distances squared. Using this relation allows us to not have to worry about the mass of the object. Next, we determine the values that are given. We know that the old gravitational force is 392 newtons, the mass of the object is 40 kilograms, the old distance is the radius of the Earth, and we know that the new distance is 2 times the radius of the Earth because the object is lifted to a height equal to Earth's radius. Basically, it's radius of the Earth plus the radius of the Earth. And of course, we're trying to find the new gravitational force. So after some careful substitution, we notice that the RE's on the right hand side cancel each other out, and we are left with 1/4 on the right hand side. Next, to isolate the new gravitational force, we do some cross multiplying, and we end up with 392 newtons divided by 4 on the right hand side, which gives us 98 newtons. Therefore, the force of gravity at a height equal to the Earth's radius is 98 newtons. And from this problem, we figure out that knowing the distance doubled or squared allows us to divide by 2 squared or 4. Finally, a quick check of our units tells us that they are correct. The second question about universal gravitation asks us, the gravitational field a certain distance from Mars is 3.6 meters per second squared. What would be the gravitational field at 2.5 times this distance? Again, we use the inverse square law, which states that the new gravitational field equals the old gravitational field divided by the distance squared. And now we determine the values that are given. The old gravitational field is 3.6 meters per second squared. The distance, which is a factor of 2.5, and we are asked to find the new gravitational field. Then we substitute in our given values 3.6 meters per second squared divided by 2.5 squared to give us an answer of 0.576 meters per second squared. Therefore, the gravitational field at 2.5 times the distance is 0.576 meters per second squared. Finally, the unit check is shown here in blue.